problem. A puck of mass, just like a hockey puck, mass 0.5 kilogram, moving at 2 meters per second in the positive x direction on ice, collides with a second puck of equal mass initially at rest, V2I equal to 0. After collision, the first puck moves at an angle 30 degrees and the second at an angle negative 60 degrees. Find the velocities after collision. There is one thing that you need to know. If after collision, if the two objects move away at right angles, it indicates that the collision is elastic. So in this case, if you notice, the first puck moves away at an angle 30 degrees and the second puck moves at an angle negative 60 degrees, means the angle at which they move away from each other is 90 degrees. Therefore, the collision of the two hockey pucks on the ice is elastic. Okay, there we have M1 equal to 0.5 kilogram, V1I is 2 meters per second I to the right, V1F is at 30 degrees. We don't know the value of V1F, we need to find the value. There, M2 is 0.5 kilogram, initially at rest, and V2F you need to find. You know it is at an angle negative 60 degrees. So here comes the first puck. It hits the initial velocity 2 meters per second. It hits the first puck and it goes at an angle 30 degrees. That is V1F. At an angle 30 degrees, and the second puck moves at an angle negative 60 degrees. There you are. And we now need to find V1F and V2F. Well, we are looking for V1F and V2F. Let's write V1F in the component form. How do you write V1F in the component form? It will be V1 cos 30I plus V1F sine 30J. So V1F is V1F cos 30 degrees I, its x component, and V1F sine 30J, its y component. Similarly, V2F is V2F cos negative 60 degrees I plus V2F sine negative 60 degrees J, the x component, the y component. The momentum is conserved in both x and y direction. Now, when we say momentum is conserved in a collision, it means momentum is conserved in the x direction. That means the initial momentum in the x direction equal to the initial momentum in the initial momentum in the x direction must be equal to the final momentum in the x direction. Similarly, the initial momentum in the y direction must be equal to the final momentum in the y direction. So, conservation of momentum means momentum is conserved in the x direction as well as in the y direction. Momentum is conserved both x and y directions. Alright, using conservation of momentum in the x direction, we have momentum, initial momentum in the x direction equal to initial momentum, I'll say it again, initial momentum in the x direction equal to final momentum in the x direction. Alright, what is the initial momentum in the x direction? It is the initial momentum of the first puck. The initial momentum of the first puck is 0.5 kilogram times 2 meters per second I. That is 1 kilogram meter per second I. That is the initial momentum of the first puck. What is the initial momentum of the second puck? The second puck is initially at 0. So the initial momentum there is 0. Therefore, the initial momentum in the x direction is this plus 0, that is 1 kilogram meter per second. This is the initial momentum in the x direction before they collide. The final momentum of the first puck in the x direction is 0.5 kilogram times V1F cos 30 degrees, because the velocity of the first puck in the x direction is V1F cos 30 degrees. Now, the final x momentum of the second puck is its mass times its x velocity, that is 0.5 kilogram times V2F cos negative 60 degrees I. That means if you now add these two quantities, that will be the total final momentum, and that must be equal to the total initial momentum. So PXF, final momentum in the x direction, is this quantity 0.5 V1F cos 30 degrees I plus 0.5 V2F cos negative 60 degrees. Use your calculator to simplify these values. 0.5 times cos 30 degrees is 0.433. So the first term is 0.433 V1F, and the second term is plus 0.25 V2F. So the PXF, the final momentum in the x direction, is 0.433 V1F plus 0.25 V2F. And this must be equal to this quantity, 1 kilogram meter per second. So total initial momentum equal to total final momentum in the x direction. So we got one equation connecting V1F and V2F, looking at the conservation of momentum in the x direction. In the same way, we can now take the conservation of momentum in the y direction to obtain a second equation consisting of V1F and V2F. So using conservation of momentum in the y direction, we have initial momentum in the y direction, PYI, must be equal to the final y momentum, PYF. Now tell me, what is the initial y momentum? Initial y momentum is 0 for both puck. There is no y motion. So PYI equal to 0. Initial y momentum is 0. What is the final y momentum? The final y momentum of the first puck. What is the y velocity of the first puck? V1F sine 30 degrees. So that will be its mass times its y velocity. This is the y momentum of the first puck after collision. What is the y momentum of the second puck after collision? Its mass multiplied by its y velocity, which is V2F sine negative 60 degrees. That means the total final momentum is 0.5 V1F sine 30 degrees J plus 0.5 V2F sine negative 60 degrees J. This is the final y momentum of the two pucks. And simplifying that gives me 0.25 V1F minus 0.433 V2F. And this quantity must be equal to 0. So we have 0.25 V1F minus 0.433 V2F equal to 0. We have now two equations. Equation 1 and equation 2. And I have shown you how to solve equations like this on the calculator. So use the calculator TI-83 or any other calculator to solve this system of equation. It gives me V1F equal to 1.73 meter per second and V2F equal to 1 meter per second. Now that has been a very good problem, and I want you to practice these kind of problems. I know I rushed a bit on this lesson, but a very important and crucial lesson. Please, after listening to the lesson, do all the homework and get back to me if you need any help. Okay, now this ends Unit 4. That means you are now ready for, is it Unit 4 or Unit 3? Unit 3. This is the end of Unit 3. And we are now ready for Test 3. So go through the practice test and make sure that you understood all the concepts. Very important to know the concepts. And you can solve simple problems. Alright? I will see you for Unit 4 later on.